All right, this lesson is going to be about common logarithms. So remember when I was talking to you guys about that there's a log function or a log button on your graphing calculator? This is when we're going to be using it. Okay, a common log is a log of base 10. Okay. When this is written, it'll actually, because it's a common log, they won't have the base there, so it'll be just log x equals a. All right. Before we move on, if you do not have a graphing calculator at home, or if you do not have a calculator with the log button, it's going to be kind of tough to answer your questions. So you need to go to desmos.com. This is a great graphing calculator site that you can use and type that stuff in. That way you can get your numbers. Okay, so to start with, we're first going to start with just figuring it out on our calculator what to type in. All right, so I'm finding the log of 60. I can just type this right into my calculator, and I'm going to get 1.778. Okay, so let's find the log of 6, and then the log of 0.6. So if I look at this, the log of 6, once I type it in, is 0.778. The log of 0.6 is negative 0.2218. Okay, so there is some correlation here between all of my logs. So if I'm looking at the log of 60 and the log of 6, what's going on? Notice the decimal place is still the same, but the log of 60, I have a 1 in front of it. Okay, how do you go from 6 to 60? You're adding a 10 spot, right? So if I'm going up here, I'm adding 1. Okay, now then I added a 10, so I added plus 1. So let's look at the log of 6 to the log of 0.6. I'm subtracting a 10, or I'm going away from a 10 spot, I should say. I'm dividing by 10. Well, in the green, we went plus 1. So in the blue, we're going down. So we're subtracting 1. So how does this look for us? The log of 60 can be written as the log of 6 times 10 to the first. And we know that 10 to the first is just 10 times 6 gives us 60. That makes sense. Okay, log of 6 is just log of 6. And the log of 0.6 is really the log of 6 times 10 to the negative 1. Okay, so what does this mean? Why does it matter? Here's why it matters. We need to find what is called a mantissa. A mantissa is where our logarithm is our number times 10 to the 0, aka log to the 6. Okay, whatever that equals is my mantissa. So in our case, 0.778. Your log to find your true mantissa has to be a single digit in your 1 spot. Okay, so you can't have a 10 or, a hundreds, whatever. It's got to be a single digit or a single ones column, okay? So there's another part of this. There's also what we call a characteristic. A characteristic is the number that you're adding, so plus 1 or minus 1. So in our case, this is also represented with your 10 to the whatever your exponent is. In our case, if I were to say, looking at the log of 0.6, my mantissa is 0.778, my characteristic is then negative 1. We're going to look at another example before you guys get your problem, so just relax. Let's say that I have the log of 28.4, and I want to find the mantissa and the characteristic. So what I'm going to do is I'm going to plug the log of 28.4 right into my calculator to see what it equals. This is approximately 1.4533. Just to kind of give you a heads up, the book will ask you for 4 after the decimal place. So with this being said, I can move my decimal here to find my mantista. Okay, so if I move my decimal and I find my mantista is 0.4533. Notice if you're looking at here between the two, I'm moving my decimal, I'm dropping the 1, so it's just what's after the decimal. Be careful though. This only works if you're moving your decimal to the left. So then my characteristic, you can rewrite it if you want to find the 10 to the whatever, but if I know I'm moving the decimal and I can see that it's approximately 1 point something, I know my characteristic is 1. Okay. Final answer. So for you guys, I've got the log of 724.8. So I would like you to find the mantista and the characteristic. Looking at this, I go ahead and plug it right into my calculator, which is 2.8602. So my mantista, I'm just going to go ahead and just cut off the 2, is 0.8602. My characteristic is then just 2. Notice if I add the mantista and the characteristic together, they will, added together, their sum will give me the log. Remember, the other thing to this, your log or this 724.8 cannot be a negative number. Just a helpful hint. All right, and the last thing we've got to talk about is an anti-logarithm. Or an anti-log. So what this means is if I have the log of x equals a, then x has to equal the anti-log of a. All right, so let's work over here with the left. We know that this is to the base 10. So let's write it in exponential form. Exponential form gives me 10 to the a equals x. Well, going into this exponential form is what your anti-log is. Okay, so let's say, for instance, what's going to happen is they're going to give you the a value, and you're going to have to find and solve for x. And they'll ask you, they won't say solve for x, they'll say find the anti-log. So let's say, for instance, a is 1.42. So again, I know that the anti-log is really exponential form. So I have 10 to the power of 1.42 to equal x. Well, I can just plug that right into my calculator. And I see that x equals 26.3027. All right, not too shabby. So for you, you're going to find the anti-log when a equals negative 2.83. When I'm finding my anti-log, I know that it's 10 to the power of a equals x, so I go ahead and take 10 to the power of negative 2.83, and I just plug that into my calculator. Make sure if you have that negative there, make sure you're using parentheses. Otherwise, it's going to goof up on the order of operations. X, therefore, equals 0.0015. That doesn't look like a 0. Final answer.